So today we're talking about slope, and we'll just talk about a couple of things that slope is, and we'll come back to add some more things as we learn some more in the next couple of days. But we know that slope, when we were talking about the tile patterns, is the number that's being added over and over again. And we know that it's how fast something is growing. And you probably figured out today that the steeper the line, the bigger the number. And it's always going to be the rise or the vertical over the run, which is the horizontal. And we also call that the change in y over the change in x. So the ways to find the slope, if you have a graph, you're just going to go ahead and find the slope, draw a slope triangle, and look for, once again, that change in y, or the vertical distance, over the change in x, which is the horizontal distance. So in this case we have a 2 for every 1, or if you'd made the bigger triangle, or any bigger triangle, this is going to be 4 for every 2. So the slope is the change in y over change in x, and we can simplify that. That's as simple as it gets. So in this case, the slope is 2. Now, if we have an equation, like the equation of this up here, it is, we know the slope is 2, so the slope goes right in front of the x because it's growing 2 times for every x number. So if x was 1, it'd be 2 times 1. If x was 3, it'd be 2 times 3. And then we always need to know the starting number. And that starting number is right there. I'll make it in big and yellow. So that starting number is always that b. So this one's -2, I believe. So finding the slope, you can draw a slope triangle, and you have the graph. If you have the equation, it's sitting right in front of you, in front of that x. Let's say you don't have the graph, you just have 2 points there on the line. Let's say the 2 points you have are 1, 3, and 4, 5. And so you can just you can graph them if you wanted to, but the other thing you can do is you can just go ahead, and I always make a table, it's easier for me. So I put it in a table for me. And then I find the change in y. Here's the x and the y, change in y. So this going this direction, it's going up 2. And then the change in x is going up 3. So we have a slope of 2/3. That means it's going up 2 for every 3 over. Okay? Up 2 for every 3 over. And there's my slope triangle if I wanted to draw it. So I want to go ahead and highlight this for you. You may have seen the slope formula before. It's just, it looks confusing. y1 minus y2. Basically, you're just finding the change in y over the change in x. And you can do it with the table, you can do it with the formula, you can do it any way you'd like. So I'd like you to, right now, stop the tape and go ahead and do these 2 examples. And I'm going to move this over so you can go ahead and do those 2 examples. Stop it, do them, and then we're going to check, okay? So this first example, the change in y, 4 minus 0 is 4. And 1 minus 3. So whatever direction you go with the x, with the y's, go do the same thing with the x's. So 1 minus 3 is -2. So if I simplified that one, 4 divided by -2, that would be -2 over 1, or just -2. So the slope here, and remember slope is the m, and y equals mx plus b, is -2. This one, once again, I like to put things in a table. It's easier for me. This one changes 12 for every 4. So we have 12 over 4 is a slope of 3. Okay? So there are 4 kinds of slopes. When it's heading, we always read a graph from left to right, right? From left to right, from left to right. And this particular one, since it's heading up, is considered positive. Oops, it's positive. This one's heading down, so it's negative. This one right here, take your notes neater than me because we're going to put more on this and that. This one that's flat or horizontal, the slope is 0. And then this one that's vertical has an undefined slope because you'd be dividing by 0, and that's unacceptable behavior in mathematics. So remember, heading up, always read from left to right, positive. Heading down is negative. We'll show that with numbers as well in just a second. So I'm going to erase all of this stuff. And start paying attention to the equations themselves. And so I'm going to go ahead and blow this one up. And you can go ahead and look. But there's lots of places that you could draw your slope triangles, but it's important that you're picking what's called a lattice point. So you can take the shortest distance between 2 lattice points or the longest distance, and it's still going to simplify. So I'm going to pick this particular. I don't think this one's actually a good lattice point. I don't think that one's good. I think it's actually right here. UPS guy just showed up, so I had to stop for a second. Okay, so here we've got our lattice point. So I can take the short distance to find the rise over the run, and this one rises 1 for every 4. So we could right away write it as 1 over 4. But if we wanted to go ahead and go from this point to this point, it rises 2 for every 8. This distance right here is 8. When those simplify, you still are going to end up with a slope of 1 for every 4. And so this is how this one grows. For the equation, we need not only the slope, which we put right in front of the x, y equals 1/4 x, but we need that y-intercept, which we find where it crosses the y-axis. Here's our y-intercept. It's always when x is 0, so in a table you can find it there. And so this one is 1/4 x minus 2. This negative one, when you look for your slope triangle, once again, it doesn't matter if you use the closest distance between 2 lattice points or a big triangle, it's still going to simplify. This one has a change in y of -3 and a change in x of 1. So we have a slope of -3. And that's gonna be our slope. Oops, gotta get my pen. -3. And so now we have one of the 2 pieces of information we need for the equation. We need the slope. It's dropping by 3 each time, so that's why it's multiplied by x. It's dropping by 3, dropping by 3. And its y-intercept, it's starting at right there, 0, 3. So that's what we're going to continue our equation with, -3x plus 3. Then we get to the 2 weird kind of linear things, ones that are horizontal lines. This horizontal line has a y-intercept of 0, 1, and it's got a 0 slope. So we can write that equation as y equals 0x plus 1, or we can just write it as y equals 1. So the horizontal guy is its own special kind of line, and it has a 0 slope. And then we have the last kind, which is this one. And this is a special kind of line that's vertical. It doesn't have, that's not a word. It doesn't have a slope, it's undefined. We don't, because you'd have to, the change in y is 0, and the change, no, whoops. The change in y is infinity, and the change in x is 0, and you can't do that, so it's undefined. The equation for this one, we just write x equals -1. I think I put the line on the wrong thing there. Anyway, moving along.